beginning trigonometry. Are we going to be talking through my video? That would be bad. This is your beginning lesson on trigonometry. And the first thing I need you to review or remember is that in a right triangle, there's two legs and a hypotenuse. It's easy to spot the hypotenuse. It doesn't touch the right angle. The other two are legs, and we have to be careful that we don't get our legs mixed up. So in trigonometry, the two legs have different names depending on what angle you're dealing with. So if you are standing over here by R, then this leg is called the adjacent, which means right by you. The adjacent leg. And the other leg way on the other side, the far side, is called the opposite leg. However, if instead of standing by R, you would happen to be standing over by S, now they trade names. Now this is the adjacent leg if you're standing over by S or dealing with angle S. And the far one would be called the opposite leg. So remember the two legs have different names and it depends on which of these two angles you're dealing with. And we don't usually talk about sines and cosines and tangents of the right angle, just the two acutes. Now you have your sheet in front of you already. So I would like you to notice that sine is always opposite over hypotenuse. Sine of an angle is opposite over hypotenuse. Notice that cosine of an angle is always adjacent over hypotenuse. And tangent of an angle is always opposite over adjacent. These would be very good things to memorize or have on a card. Right. Let's start by doing number 1, sheet 28. In number 1, and Abby will be doing it live on the screen with me. Number 1, we have a triangle that is not quite like this one. This time our triangle is ABC.
Oh my goodness. Whoa.
This is so awkward. Yes, it is. Look at watch.
You might want to just set that down.
Okay, well,
All right. Keegan, since we're finding sine of angle A,
there we go. Good enough.
do you think we're considering ourselves over at corner A or B?
We are considering ourselves at corner A.
Very good. Very good. Remember, sine is opposite over adjacent. Hypotenuse. They are all numbered, so in this one, Keegan, that would be what number over what number?
That'd be 30
Yeah?
over 34.
Notice how he has cleverly chosen the right two sides. He has looked at the A, it's right there, and he decides we're over here at corner A. And then since sine is opposite over adjacent, the key knows that opposite leg is one way on the other side. And it's got to be over hypotenuse, which is the side that doesn't touch the right angle. So right now, Abby is going to write right behind here equals 30 over 34. Does that reducible, people?
Yeah.
What could she write that'd be the same fraction reduced?
15 over 12.
The
5
people in the
over-
audience are suggesting a 15 over 17, so write equals 15 over 17. Abby has shown you how to get the first one right. Paige is going to help us now. Paige, for number 2, they're talking about the tangent of B. Where should we consider ourselves standing, Paige? Nice, up here at B. Paige, if you're standing at B and trying to do an opposite over hypotenuse, that'd be what number over what number?
16 over 34.
Do that, Abby. She said, what did you say?
16 over 34.
I wrote it wrong. Gee.
Oh.
Okay, Abby, if I write it right, now what would it be?
16 over 30.
Nice. Can you do that, Abby? That was my mistake, that little mess there. Oh, is it reducible?
Yep.
Give them an 8 over 15. They want an 8 over 15. So 8 over 15 is considered the tangent of that angle. Jacob,
It says to put like decimals too. Are we just skipping the decimals or no?
they want decimals? We can do that.
Come on.
You gotta be kidding me.
It's not.
Come on, horse.
You just do
Kelly's ready. Kelly, what is a 15 divided by 17?
0.9.
Come on, horse.
Say that again.
Horse.
0.9.
We want more.
0.88235.
8823. We're giving it 8823. Kelly, what's an 8 divided by 15? 4 digits, please.
0.5333.
Nice. Nice.
583.
One more time, Kelly. She didn't quite catch that.
0.5333.
Stop it.
We're going to do one more and flip the page. I'm going to use Mackenzie for my help. Mackenzie, I'm looking at number 8. Number 8 says cosine D. So are you already picturing yourself standing right there on D? Go there. Okay, she's there. And cosine is what over what, Mackenzie? What numbers does that look like it should be? Jason leg be the leg right by you. She says 12 over 20. Kelly, quick. 12 divided by 20. Things like 0.6, isn't it?
Yep.
0.6000. No
You want me to
messing
put the
around.
zeros?
Nice. We are turning the page.
Whoa, what? There wasn't a fraction.
Oh, it's 12 over.
Yeah, 12. You're gonna have to write it though. This is so awkward.
Okay, can we get
It's
pointed at
upside
that
down.
number 1 there? This kind of got to go like that. Whoa, this needs to be tightened. There's your problem. 3. All right. Alright, the triangle here. I could draw a better one right here, maybe.
It's not focusing.
It's got a
People to write.
holders. Land that thing. Okay, we've got an X there And what's along the bottom right here?
32,
32. And they've got an angle right here. What is that?
28.
28. All right. Celine, we're going to try to figure out X together, you and me.
This thing is.
And if we're going to use that 28 degrees there, we have to think like we're standing there. You understand? So that's the corner we're going to picture ourselves standing by. Celine, what would be the names of these two sides then if we're standing over there?
The side 32
So that's adjacent and opposite. Which of the formulas has adjacent and opposite in it?
tangent.
Nice, nice. So this is the beginning step of work. Tangent of the angle is equal to, is it opposite over adjacent or adjacent over opposite? So x over 32
proportions that I'm just going to slip a little over one so that you can see it in a familiar arrangement of proportions.
Can you see, Celine, that x times 1 has to equal tangent 28 times 32? I have a calculator puncher up person right in the front row. She's wearing pink. She's got a pink calculator, pink notebook. She got just like all pink. Can you give me a pink answer?
Sure.
Tangent of 28. Now, I don't know how her calculator works or yours, but most of them, you push tangent and then put 28 in the parentheses. But a few older calculators, you push 28 and then hit the tangent button. So you better check out how yours works.
I got 0.5317.
That's for the tangent of 28?
Yes.
So she got 0.5 something, and you should take that times 32, Kelly, because that's the cross multiply plan. And you should be getting like 17-ish or so.
17.01.
17.01. Nice job, Abby. All right, I think we should do another one of these. That's kind of new for us. This time I'm going to use Matt. Matt, this time I'm going to go ahead and do number 2. You ready to help me with that? I'm going to erase this one. There's a new triangle now. Are we stabilized for number 2, Katie? I'm going to make this triangle a little bigger so the people at home can see it. Oh my. And Matt's got like a 16 there and a 12 there and an X for the degree. Matt, they don't give us the angle this time, right? All right, Matt, if we're going to find this angle, then we got to picture ourselves standing over at that corner, you understand? So are you there? He's there. So Matt, the two sides that we know, what are their names now then?
The hypotenuse and the opposite leg.
All right, so he says it's which of the three things has hypotenuse and opposite in it? So we should do sine of the angle, which we don't know, equals, is it opposite over hypotenuse or hypotenuse over clear around it?
Opposite leg.
Kelly,
Yep.
on your calculator, can you do a 12 divided by 16?
0.75.
So that means, Matt, that we know that the sine of this angle is 0.75. And we don't know the angle, but we know its sine is 0.75. So it would be kind of dumb for us to take the sine of 0.75, because this is what you get when you take the sine of the, we gotta somehow do a unsine. We got the sine, we gotta get back to the angle. That's what the shift button on your sine is for. Most of them say something like this, a little to the minus 1 power. And you do the shift sign of 0.75. And then it should give you the angle. Is yours able to do that, Kelly?
Yep,
You can do an unsigned?
yep.
What'd you get?
48.5903.
48.59, let's make that 0.6 degrees. You can check this, Kelly. Can you take the sine of 48.6? Is that about 0.75? The sine of that? Like, just use regular sine button of 48.6. Does it give you about that? He's checking.
You say yes.
So apparently her calculator does a pretty good job of unsigns, because if you take the sine and then the unsign, you should be able to go back and forth between the same two numbers.
It's probably the best thing you can do.
I'm turning the page.
You kind of stay.
I'm on page 30. I'm on page 30, number 1. They have a nice picture like this.
The weirdest.
That's okay.
And if I put their givens on the picture, I believe we get something like this. So I think for number 1, we're kind of given that. And they want us to find the sine of r, the cosine of r, the tangent of r, sine of s, cosine of s. They want us to find like 6 things, Abby, so you gotta leave room for 6 answers here. So for the first one they want is sine of r. Matea, where should we picture ourselves standing if we want to find the sine of r? On the r. She's good. She's good at this. If you are there, if you are on that r, wait, Matea, sine is what over what? You might have to flip back there. What is sine again? Opposite over hypotenuse. So if you're standing on this r, and the sky behind you is going all over the place, what is opposite over hypotenuse? She said 16 over 34. So, Kelly, what is 16 divided by 34?
0.4705.
Abby's putting down point 4705. Mitch. Next thing they want is cosine of r. You have any idea how to do that? Cosine of r?
The cosine? That'd be 30 over 34.
Nice job. Punch that up, Kelly. He's picturing himself here, which makes Jason over hypotenuse a 30 over 34. And Kelly says that 30 over 34 is equal to
0.8823.
0.8823, Abby.
And put that for
Cosine. of R. Okay. For tangent of R, where are you picturing yourself standing at? Oh, very good. And what is R again? What over what?
Opposite over adjacent.
Opposite over adjacent. So if you're standing at R, opposite over adjacent is what number over what number?
60 over 30.
Kelly, she wants you to do a 16 over 30.
0.5333.
0.5333, Abby. For tangent of R. And now they have three other ones, sine, cosine, and tangent of S. Nick, where ought a person picture themselves to find the sine of S? So we should move ourselves now over to S. If you're at S, what is opposite over hypotenuse? 30 over 34? Very nice. 30 over 34, Kelly?
0.8823.
0.8823. Hey, we just had that, didn't we? Well, that kind of makes sense. The one that was adjacent when you're standing here is opposite when you're standing over here, so the cosine of R will equal the sine of S. I'm guessing that the sine of S is going to equal the cosine of R. So you can just as well put for your cosine of S 0.4705, Abby. Just copy that other one over there. Celine, when we did tangent of R, we did 16 over 30. How about when we do tangent of S?
30 over 60.
Kelly, we never did a 30 over 16. We're going to have to do that, 30 over 16.
1.875.
Nice, 1.875. Number 4. I'm jumping to number 4. Number 4 just says the tangent of 23. Tanner, does your calculator do tangents?
I think so.
Tanner's going to see what he gets on his calculator for a tangent of 23.
Yeah, I got 1.58.
Does that check with you? Can anybody confirm that?
I got that too.
Wait, what was it?
4.244.
What do you get tonight?
1.58.
All right. There is something we have to worry about. Some calculators will do tangents in both degrees or radians. So you have to know how your calculator works. Tanner, looks like you have a graphing calculator there.
Yeah.
You got a mode button. Hit that mode button. Are you in radians or degrees?
I'm in degree. No?
Whoa. You need.
I'm in radian.
Well, you better switch that over to degrees and try it again.
I got 0.42.
Is that what you were saying, Kelly? We should go down a 0.42, Abby.
Number 4.
Number 4 is 0.42. I should get a left-hander next time for this job. That's all right. Tanner,
Yes.
does your tangent button have a little tan -1 above it?
It does.
That means your calculator is capable of doing untangents. So on number 13, Tanner, they want us to find the angle that has a tangent of 0.41. So you're just going to do the untangent of 0.4168. Tell me then, Tanner, what? Hey, Tanner, that's funny. All right, what angle has a tangent of 0.4168?
I got 22.626.
22.6 degrees, Abby. 22.6 degrees, he's saying, for number 13. That's the extent of our lesson today. Now signing off. We will probably only